Piranha solution is an extremely corrosive mixture of hydrogen peroxide and sulfuric acid that eats through almost any organic material it touches. Its destructive nature has led to a variety of iconic videos, including vaporizing chicken in acid, and piranha solution eats stuff. But there's a big problem. It just isn't corrosive enough. That might sound insane to most normal people, and even most chemists, but I like my chemicals extra spicy. So today, I figured I'd spice up everyone's favorite acidic mixture with an extra ingredient: sulfur trioxide.
You serious?
Now, in case you have no idea what sulfur trioxide is, think of that scene from Alien where the alien's blood melts through the entire ship. That's basically this stuff in a nutshell, scary fumes included. Traditionally, sulfur trioxide is made in the lab by distilling sulfuric acid with some kind of dehydrating agent. Phosphorus pentoxide is by far the most popular and highest yielding, but it can be kinda hard to get. Its much more accessible cousin, pyrophosphoric acid, can be made by cooking down regular phosphoric acid, and it works pretty well, but it will mess up your glassware. A better option is to use sodium pyrosulfate, which is made by heating sodium bisulfate to around 400 degrees Celsius. Sodium bisulfate is commonly sold as a pool pH adjuster, and Nerd Rage was able to use it and a simple lab hot plate to get a roughly 25% yield of sulfur trioxide. His methods were a bit labor intensive and low yielding though, so I figured I'd try a different approach: brute force. The previous methods are attractive to amateurs mainly because they require relatively low temperatures in order to work. But if you can reach 800 or even 900 degrees Celsius, things suddenly become a whole lot simpler. Many sulfate and bisulfate salts will decompose directly into sulfur trioxide, including the sodium pyrosulfate made from heating pool chemicals. No extra ingredients needed. The process isn't perfect though, and the startup cost can be kinda high if you don't already have a high temperature kiln and a fused quartz flask. That said, let me show you the process that worked for me. To start, about 270 grams of sodium bisulfate was added to a 250 milliliter quartz flask. Quartz glass is mandatory since regular glass will soften and begin to melt before the maximum temperature is reached. This flask was positioned inside an electric kiln and covered with a thick layer of insulating ceramic wool. Then an adapter was connected with a receiving flask and the temperature was raised to 400 degrees Celsius. As the temperature increased, the bisulfate began to melt and release water along with a small amount of sulfuric acid. Sodium bisulfate decomposes into sodium pyrosulfate and water, starting at roughly 280 degrees. And above 460 degrees, the pyrosulfate continues to break down, forming sodium sulfate and the desired sulfur trioxide. Unfortunately, there is a lot of overlap between these reactions, which is why some acid inevitably distills over with the water, and why it's practically impossible to collect only water in sulfur trioxide. In my case, I waited until very little was distilling off at 400 degrees, and then began ramping the temperature up by 100 C every few hours. At roughly 550 degrees, thick white fumes began to fill the flask and leak from the gas outlet. This indicated that sulfur trioxide was beginning to distill over, in the form of oleum, which is a solution of sulfur trioxide and sulfuric acid. So I swapped out the receiving flask and began collecting my product. Now, while that's going on, let me show you just how immensely corrosive oleum and sulfur trioxide can be. Look at that. Even a tiny drop from the vapor outlet was enough to immediately char paper. And when dripped directly onto a piece of paper towel, the results are pretty crazy. With other acids, you generally have time to at least rinse them off. That's not the case with oleum. If this gets on your hands, there are no second chances. So, if you ever find yourself working with sulfur trioxide or solutions of it, remember to wear thick gloves and heavy PPE. Seriously, look at how much protection these professionals have on to deal with just a small spill. Also, do not mix oleum or sulfur trioxide with water. The result is almost always a steam explosion and a cloud of toxic vapor. Anyway, after several hours of constant heating, I held the temperature at 800 degrees for another hour or so, and then cut the power, allowing everything to cool slowly to avoid stressing the quartz glass flask. In total, I got 55 grams of oleum, with a roughly 40% yield of sulfur trioxide, assuming the oleum was 65% concentrated based on its melting point. A few people on the Science Madness forums have claimed yields higher than 60%, meaning I probably began collecting a bit too early, while water was still coming over. 500 degrees Celsius probably would have been a better preheat temperature to convert most of the bisulfate to pyrosulfate, It might have also helped to seal the gas outlet with a bit of glass wool, but overall, I'm quite pleased with the results. Now, let's try something I don't think anybody else has dared to try yet. Making piranha solution with oleum. As I alluded to earlier, piranha solution is normally made by mixing 98% sulfuric acid and 30% hydrogen peroxide. We all just saw how caustic sulfur trioxide and oleum can be by themselves. So what happens when they're mixed with not 30%, but 50% hydrogen peroxide? To answer that question, I cooled 2 grams of peroxide in an ice bath, and set up an addition funnel with 7 grams of cold oleum. In theory, these amounts should react to destroy all of the water and leave behind a mixture of pure hydrogen peroxide, pure sulfuric acid, sulfur trioxide, and peroxysulfuric acids, which is a frankly terrifying combination with the potential to be explosively unstable. Understandably, I was expecting this reaction to be extremely violent, similar to when oleum is added to water. But when I opened the stopcock, it was surprisingly tame. Keeping everything cold and performing the addition slowly was definitely the right move. I'd say it's time to have some fun. For my first test, I decided to drip some of the acid onto a piece of paper towel. Yeah, if the normal stuff is called piranha solution, then I'm calling my new mixture Barracuda solution. This concoction is seriously more corrosive and faster acting than almost every acid I know of. Don't believe me? Let's check out its reaction with sugar. For comparison, here is regular sulfuric acid. It reacts with sugar slowly and forms a gooey blob of carbonized residue. Oleum is a bit faster, but the effect is pretty similar overall. Piranha solution is a big step up, but it takes a moment to get going. And with 85% hydrogen peroxide, as shown by Tom from Explosions and Fire, the piranha solution doesn't even initiate without either heating or prior carbonization. With this stuff though, it reacts at room temperature within seconds, and the damage is done almost immediately. The difference seems to be thanks to the sulfur trioxide, which rapidly kickstarts the carbonization, heating, and subsequent oxidation. And speaking of oxidation, one common piece of advice is to never add organic liquids to piranha solution, since they can react spontaneously and potentially explode. Naturally, I decided to test this with my Barracuda solution. Ethanol didn't ignite on contact, but after lighting it with a torch, it did seem to behave like a proper oxidizer. I'm sure things would have been a lot more violent on a larger scale, but I think I'll leave exploding acid for another day. For my last test, I knew that I'd have to test the acid's effect on flesh. At room temperature, the effect on turkey was shockingly disappointing, so I tried completely submerging the meat in roughly 10 milliliters of hot Barracuda solution. It took about 15 seconds the first time, but this first reaction evidently heated the solution up quite a bit, because the next piece of meat disintegrated much more rapidly. Alright, I think I'll end the video here, before I inevitably hurt myself. If you enjoyed watching, be sure to like and consider subscribing to my channel. I'm creating a lot of cool stuff, including an actual plasma rifle with the same energy as a 50 BMG, a band performance enhancer from Bug Spray, and a tornado probe with a 360 camera inside it. Oh, and I'm also replicating the Coca-Cola secret formula with the help of mass spectrometry. So yeah, be sure you stick around. As always, a big thanks goes out to all the dedicated LabCoatz patrons. Without them, I probably wouldn't be able to afford most of my projects. Remember to like, share, and subscribe, and I'll catch you next time. LabCoatz out.